Hi there. In this video we're going to look at finding the volume of frustums and we're going to look at easier questions in this video where we're told the original height of the pyramid or the cone that the frustum was taken from. That'll make a little bit more sense once we've gone through what a frustum is. So a frustum is the name that we give to a pyramid that's had its top cut off. So here we've got a pyramid and the part that's been cut off is this green part at the top and the black shape that we're left with is called the frustum. Now our general strategy for finding the volume of a frustum is we want to find the volume of the small pyramid, so V small, using this formula. We want to find the volume of the whole pyramid, so let's just draw that on in red. So we'll call that V big. So I want to find the volume of the whole pyramid, and then the volume of the frustum we know is equal to the whole pyramid take away the small pyramid. Okay, and it turns out that that's much easier if you're told what the original height of the pyramid was before it was chopped than if you're not. Okay, but we will look at both. Just in this video we'll focus on the slightly easier version where you're told the height of the full pyramid. If you're stuck on a question whether that's not the case, skip over to the next video and we'll go through how to deal with that. Okay, so let's have a little bit of a look at this example here. So we want to find this area of the volume, of this black frustum, and we're told that this black frustum has been made by taking a pyramid and chopping this top piece off of height 2 and to leave us with this black frustum. Now let's just specify these are all centimetres. Brilliant. So we've got 3 steps. We need to find the volume of the big pyramid, we need to find the volume of the small pyramid, and then we need to subtract them to work out the volume of the frustum. Okay, so first thing we need to do, let's start off by working out the volume of this big pyramid. So V big. Okay, so the volume of the big pyramid is 1/3 times by the area of the base times by the height of the big pyramid. Okay, so now the area of the base of the big pyramid, and well, since it's a square, it's quite easy to work out what the area is. Can you figure out what the area of the base of the pyramid is? Yeah, 81. If you're thinking 81, that's really good because we do 9 times 9. And now, don't be tricked out by this. Just take a second to think, what's the height of the big pyramid? Okay, now if you said 6, that's correct. Okay, if you said 4 or you said 2, absolutely understandable mistake. But the big pyramid, when both pieces were on top of each other, will have been 4 plus 2, 6 tall altogether. Okay, so now let's work this out. Well, 1/3 of 6 is 2, and then 2 times by 81 is 162 centimetres cubed. So that is the volume of my big pyramid. I'll underline that in red. Remember, that's my big volume. Okay, so let's have a look now at working out the small pyramid. I've done my colours all backwards here. V small. Okay, now there's a couple of ways we can do this. I'm going to do this using the same method as we worked at the big pyramid to find out the area of the base and then times it by 1/3 of the height. But I will just briefly talk about a slightly different method we can use once we get to that point. But the first thing we need to do is we need to work out what the area of this base is. Now, you might be thinking, well, we're not told any dimensions, so how can we work out the area of the base? But what we need to remember is if we chop a pyramid, then the small pyramid is a similar shape, mathematically similar, I mean by that, to the big pyramid. So it's just been scaled down by some scale factor. So remember, we worked out that the height of the whole pyramid was 6, and the height of this pyramid is 2. So what we can say is that all the lengths on this small pyramid are a third of the lengths of the big pyramid. So what that allows us to do is, well, if this side was length 9, a third of that is length 3. And if this side was length 9, a third of that is also length 3. Okay, so now we can use our formula to work out the volume of this pyramid. So it's a third times by the area of the base times by the height. The area of the base in this case is 3 times 3, which is 9, and the height is 2. So then a third times by 9 is 3, times by 2 is 6. So that's 6 centimetres cubed. Okay, now the other way we could have done this is, I know the length scale factor is a third, so the volume scale factor is a third cubed, or a third times a third times a third, which is 1/27. So if I take 1/27 of 162, I get an answer of 6 centimetres cubed, and you can check that on your calculator just to make sure it's true. But that would have also worked. The method I've done, I think, is a bit safer. I think you're less likely to make mistakes like forgetting to cube the scale factor with this, but if you are really, really confident with your similar shapes and your scale factors, that's a perfectly good, perfectly valid way of doing it. But anyway, let's finish this question off. On to our last step. So the volume of the frustum is equal to V big minus V small. The big volume we said was 162. Let's do that in red so we're consistent. 162, and the small volume is 6. So the volume of the frustum is 156 centimetres cubed. There we go. Okay, so on to our next example. So this time we've got a conic frustum. So remember we said that the volume of a cone is exactly the same as the volume of a pyramid. So this is quite a tall cone that's been chopped off, and it's been cut to a quarter of its original height. Now, these ones I said will be told the original height. We've got one step we need to do to work out the original height, but we're told enough information that that's not too difficult. So if this frustum is 3 centimetres tall, if that's a quarter of what it once was, then the original height is 3 divided by a quarter, or 3 times by 4. So the original height was 12 centimetres. So it's worth just being aware of that as we move forward. If you do want to have a go at this question, now that we've sort of worked past this bit, it does function very similarly to the last example. So pause the video now and give it a go before we can go through what's going on. Okay, so let's have a look at this then. So first thing I'm going to do is we're going to work out the volume of the big pyramid, or the big cone, which again is a third times by the area times by the height. Now I know that the original height was 12 now, and I know that the area of the base is a circle, so it's pi times by the radius squared, or pi times by 6 squared. So now we can work that out. 6 squared is 36. A third of 12 is 4. So then we've got 4 times by 36, which is 144, is that right? 36 times by 4. 4 30s are 120. 4 6s are 24, so it's 144 centimetres, or pi, sorry, centimetres cubed. So not the easiest calculation to do in your head. If I was in an exam, I'd take a bit more space over it, but I've not got a huge amount of space at the bottom here, so we'll just leave it like that. Again, I'm going to leave it in exact until the end. If you wanted to round it to two decimal places though, you could at this point, that would be fine. Okay, so now the next step is to work out the volume of the small cone. And to do that, we need to work out what this radius here is. So then we can work out the various different bits. So if this cone that's been cut off, well, if we're left with 1/4 of the original cone, the bit that's been cut off must have been 3/4 of the original cone. So this radius here, actually let's just draw ourselves a little diagram of the smaller cone. Okay, so this cone at the top is 3/4 of the whole cone. So that means this radius here is going to be 3/4 of the radius at the bottom, which is 3/4 of 6. So 3/4 times by 6 is 9/2 or 4.5. So that's equal to our radius of the top cone, the radius of the small cone. Similarly, the height of the whole cone was 12. So the height is going to be 3/4 of 12, which is equal to 9. And that is the height of the small cone. So now what we can do, V small is going to be equal to 1/3 times by 4.5 squared times by 9. Now 4.5 squared, that's a tricky one to work out. Let's do that on the calculator. $20.25. So it's 1/3 times by 20.25 pi. Oh dear. Times by 9. 1/3 of 9 is 3. 3 20s are 60. So there's going to be 60.75 pi. So the volume of your small cone is 60.75 pi. The volume of the big cone is 144 pi. So then our final answer, or the final step, is to work out the volume of the frustum, where we do V big minus V small. V big, we said, was 144 pi. V small was 60.75 pi. So I've got 144 pi and I take away 60.75 pi. That's going to take me down to 83.25 pi, which again, if we typed into our calculator, we could work out an approximate solution to that. And if you did manage to follow along at home and get that, then well done, because these questions, even though they're the easier Frustum questions, they're not easy. Absolutely. So good job.